This PowerPoint covers Pythagoras, trigonometry and bearings that you've probably met in previous years. You might find that you only need to scan through this very quickly, or you might need to practice some of the questions listed at the end of the thing. Each slide will have my explanations, and the following slide usually has the good copy, so you can copy the notes into your notebook. So proceed, and also I'll be putting some demonstrations of the use of the calculator along the way. Right, our next section here is how to remind ourselves of trigonometric problems. So the first thing we've got here, we talk about that we should label the triangle with the correct names for each side. So the three names we use for the hypotenuse is H, and that's opposite the right angle. O is opposite the angle that's marked in the question for you, and A is the third side that's adjacent to the angle. So the first thing we do is identify where the right angle is here. So opposite this across to here is the hypotenuse, so that's where I put H. This side over here is opposite the marked angle. In this case the angle is theta, just a Greek letter. So we call this the opposite. And this third side, the other second short side, is the adjacent. It's the word adjacent means next to. So the adjacent side is next to the angle. You'll notice the hypotenuse is also next to, but it is special because it's opposite the right angle. Okay, so down the side here we can see this is the process we should follow when we're trying to solve a trigonometric problem. So this question here asks to find missing links using trigonometry. So the first step we should do here is label the sides. Then the second step, based on the sides, what we've got in the question, so we label them O, A and H. Then we decide which of the three rules. Sine is equal to opposite and hypotenuse. Cos is adjacent over hypotenuse, and tan is opposite over adjacent. So you may be familiar with the saying sock, car, toa. Sock, car, toa is the way people tend to remember this. Alright, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. Once we've worked out which rule, we substitute into that's our third step, we'd substitute into the values, and then we need to solve by rearranging if necessary. So let's go through the three examples here. Hopefully this is review for you. So the first thing I would do is look at this triangle here, and 10 I can see is opposite the right angle, so that's the hypotenuse in this question, and the side X is the thing we need to find here, is opposite the marked angle, so I'd label this with O. Because the two sides I've marked are O and H, I would be using sine, because O and H appear in that rule. So we write down this, we say sine, not sin, sine, it's the correct, sin is the abbreviation, but we still say sine of 50 degrees. So sine of whatever the angle is there, 50 degrees, is going to be equal to X, is the opposite, divided by the hypotenuse. Following the rule here, opposite over hypotenuse. Okay, we do rearranging first. So this X has been divided by 10, so to get the X by itself, I'd multiply both sides by 10. So I write 10 sine of 50 degrees and then we go to our calculator and work out what X is going to be. So we simply just type 10 sine 50 degrees. I'll show you in the next slide or two how to use your calculator to do this, but when we get that, it comes out as 7.66, and this question had units in it, or centimetres, so I'm going to have centimetres in my answer. Alright, let's go on to the second one. Here I've got Y, which is opposite the right angle, So that's the hypotenuse. 6, which is this length here, is next to the angle, not opposite. This is the opposite of it, so this is the adjacent. So which rule has adjacent hypotenuse in? You can see here it's a cosine rule. So we say cosine, cos, of 40 degrees equals the adjacent over the hypotenuse. Now the difference in this problem as compared to this one here, our unknown x was on top, but here our unknown is underneath. So the method we do here is first bring that across there as a multiplier, so we get y times cos of 40 degrees is equal to 6. And that's y times, so if I want to get rid of the things times by, the thing it's times by becomes a divider on the other side. So the cos of 40 goes underneath the 6. Alright, we can type that on our calculator and I will demonstrate that in a few minutes. And you can get y is equal to 7.83. Once again, there's units in this question of centimetres, so it's 7.83 centimetres. That being my answer. Alright, we'll do the third example here. We've got Z. Z is opposite the angle. 8 is adjacent to the angle. This is the hypotenuse over here, but we don't need it in this question, so I don't bother marking it. So opposite and adjacent is tan. Okay, so we set out the rule first. We substitute in. So tan, do I know the angle? Yes, it's 27 degrees. So tan of 27 is equal to the opposite, which in this case is Z, divided by the adjacent, which is 8. This is the case where the unknown's on top, so the 8 just needs to go multiplied out the front there. So we get 8 times tan of 27. See, when I rush, the handwriting's very poor with the mouse. And this will tell me Z is equal to, if I go to my calculator and go 8 times tan of 27, I get 4.08. And once again, this question had units in it, so I've got centimetres as my length there for Z. Alright, proceed to the next slide and you'll see all this in very nice, neat version. So here you can see a much neater copy of that working out from the previous page. You'll notice that I've highlighted things that are important in the question. This is the third type of trigonometry problems that you get. In this case here, we have to work out the size of the angles in the question. So angle X is in this one here, and angle Y is in the separate question over here. There's three types of trig problems: finding when the unknown's on top and when the unknown's underneath. We did those on the previous slide. And the third type is finding the angle. Still start the same way. The first step is to label what sides you have in the question. So here you can see 15 is the hypotenuse and 8 is next to the marked angle, so this is the adjacent. So adjacent and hypotenuse, we use cos. So I'm going to do it here because we are going to use that space down below for the calculator. So we say cos of x is equal to the adjacent 8 on 15. Okay, hopefully you've seen this before. The opposite operation of cos is called cos to the negative 1, or the inverse of cos. So the inverse operation, or the opposite operation of cos, is the inverse of cos. So that's how we write it. We say to get rid of the cos on this side, it becomes cos to the negative 1. We use this when we want to find the angles. And on our calculators, and I'll demonstrate this in a moment, we can type that on our calculators, and this will give me the answer that is 57.77 degrees. Need units. It's an angle, so we're working degrees. Okay, let's go down to this one here. I'll just change colour. Alright, so here's the marked angle Y. 10 is opposite and 5 is adjacent. This one across here is the hypotenuse, but we won't need to mark it in this question because there's nothing there. So opposite and adjacent is tan, so we set this problem out, we say tan of Y is equal to the opposite, which is 10 divided by the adjacent, which is 5. And the opposite operation of tan is tan to the -1, or the inverse of tan. 10 on 5, I could have written that as 2 if I wanted to, because 10 divided by 5 is 2, but we don't need to. We can just simply type that on the calculator as it looks, and when I do that on my calculator it comes out to 63.43 degrees. Alright, that's the answer for that. And if it was a sine problem, we do sine to the -1. Okay, we'll now demonstrate how to use the calculator for this. I'm just going to insert a new calculator page, so we start a fresh, clean page. So we had our first problem before was we found the triangle where sine of 50 degrees and we had to find x, and the other side length was 10. And we ended up with, we said we could work out x by typing 10, and to get sine on the calculator there's a trig button over here on the left. So press trig and go sine, and inside the brackets we type the angle. We don't need to put the degree symbol because earlier on we changed our calculator to degree mode. And press enter, and if you press enter and your calculator's on auto like we said before, it may come up like this. So if we want a decimal answer we go control enter. Now this answer is given me as 7.66044, and if I wanted to put that to 2 decimal places, I go up, select that and go comma 2, and it gives me the answer 7.66, which we wrote before. Okay, so the next one we had to do was finding y, and we end up with 6 divided by cos of 40, so the best way to put that on your calculator is go control divide. So 6 on top, go to the box down below and go trig and cos of 40 degrees, so 40, and I'll go control enter here, and it'll give me the decimal straight up. And we said the answer to 2 decimal places was 7.83, because if you look at the next digit it's less than 5, so we don't round that number up. And the last one we had to do in that series was 8 tan of 27. Go control enter and get the answer 4.076, but when we round this one up we look at the third digit, it's 5 or bigger, so I need to round that up to 1, so 4.08, or I could use the calculator's ability to round for me, comma to 2 decimal places, 4.08. Alright, then we had the angle one. So we had the problem where the first one we had cos of x equals 8 on 15, and then we said x would equal the inverse of cos. So from the trig menu, once again you can find inverse there. Because I've got a fraction inside here, I go control divide, so it comes up with the fraction template, and I've got 8 on top and 15 below, and so I get a decimal answer. I go control enter, and here it gives me the answer 57.769, so to 2 decimal places that would be 57.77. If I was going to 1 decimal place it would be 57.8. I'll just show you that. Round that to 2 decimal places gives me 57.77, and if I rounded that just to 1 decimal place it would be 57.8. Little revision there of our rounding. And the second one we did was the tan, the inverse of tan, and we had here control divide, we had 10 over 5. I think I did mention at the time we could have just written 2 there, because 10 divided by 5 is 2, and go Control Enter, and I get 63.43. So to 2 decimal places, I need to look at that digit, it's under 5, so I just leave it at 63.43 degrees. Good. Okay, got a couple of word problems here. The first one says I've got a 2.5 metre ladder, so it's leaning against a wall at an angle of 62 degrees to the ground. And we're asked to calculate how far up the wall does it reach and to 2 decimal places. So they're the key things in this question. Alright, so first of all I would try and draw a diagram to represent this. So this will be pretty rough, but here's our wall, like here. Ground would be along here, and my ladder, I might just do this in a different colour. Can I do it in a different colour? I hope so. Here's my ladder, leans against the wall like that. It's 2.5 metres long. Okay, we make a little assumption here, the ground and the wall meet each other at right angles. So here you can see I have my right angle triangle. Also we're told that the ladder leans up against the wall but makes an angle 62 degrees to the ground. So that's down in here, 62 degrees, because it's making the angle at the ground. Okay, and what are we asked to find? How far up the wall does it reach? So this becomes my unknown. How far up the wall does the ladder reach? Okay, get a good diagram, makes the question pretty simple from there on. So now I've done this much, I can now look at my triangle, my right angle triangle, and we can see that 2.5 is opposite the right angle, so this is the hypotenuse. And the other side that we need in this question is x, and it's opposite the marked angle, so this is going to be the opposite. So I look at my ratios, SOHCAHTOA, which one has O and H? Sine. So I think we're better off going back to the red. So we say sine of whatever the angle is, in this case it's 62 degrees, is equal to the opposite, which is x, over the hypotenuse, which is 2.5. Remembering we've got to identify our unknowns on top here, so this becomes 2.5 times sine of 62 degrees is equal to x. So we go to our calculator to calculate this, reminding ourselves the answer needs to be to 2 decimal places, and when we do that we get 2.21 metres. Remembering that on the next slide there'll be a nice neat copy of all this, and you can be easy for you to read. Alright, so that's the first example there, a worded problem. Next one is, it says here's a walking ramp. It's made up of an angle of 10 degrees. So I'm highlighting the key method, and rise 2 metres up to a platform. We're asked how long is the ramp to 2 decimal places, and how far is the ramp horizontally from the platform to 2 decimal places. Once again, having a good diagram here will make a difference. So the way I read this, I've got a ramp which is going up like this and goes to a platform, something like this, but this height here is 2 metres from here to here, or to here I should say. Alright, and this length here, horizontal, makes my right angle triangle. Okay, we're told that it rises 10 degrees. So that 10 degrees is how the ramp rises. We're asked how long the ramp is. So I'm going to call this, let's call this X. And the second part says how long is it horizontally. That's that length across the bottom here. So that's Y going to be here. So I've got my right angle triangle. I might label my sides that I have here. The 2 meters high is the opposite the 10 degrees. X is the hypotenuse of this right angle triangle, and therefore Y, being the third side, must be the adjacent side. Alright, so we've got 2 calculations we need to perform here. One is how long the ramp is, that is what is X. So A, now to do A, I've got 2 is the side I've got to use, it's the opposite, and it's the hypotenuse. So I would say sine, opposite and hypotenuse, sine of 10 degrees is equal to the opposite, 2 over the hypotenuse, which is X. Here our unknown is underneath, so we need to bring him over there, and at the same time we can bring this down to here. So our next line we would write X equals 2 divided by sine of 10 degrees. The degree symbol is optional. I'd go to my calculator to calculate what this comes out to, and this comes to 11.52. Alright, there's units in this question. Our question's all about meters, so it's 11.52 meters. That's part A done. Part B says we've got to find the length. The ramp goes horizontally. Horizontal is across this way. So we're finding Y. We would be using this answer, this number here, not the one we just worked out because we may have made a mistake. We would use this and the angle. So we've got opposite and adjacent, so this is a tan problem. So part B here, it's a tan problem. So we go tan of 10 degrees is equal to the opposite over the adjacent, which is Y. Once again, we've got a problem where the unknown's underneath, so it needs to go over here, and then what's over here goes underneath. They swap positions. It's doing 2 steps in one. Cuts a bit of work out for us. So the answer for Y is going to be 2 divided by tan of 10 degrees. And if we go to our calculators and do that, we should get the answer is 11.34 meters. Okay, if you go to the next slide. Okay, much nicer, showing how we can use the calculator. The next section that we need to be familiar with is angles of elevation and depression. Okay, these have already been filled in, but we'll go through here. We're asked to draw a triangle that matches the given information. The first one asks for the angle of depression. You can see I've highlighted that. From the top of a 200-metre cliff to a boat out at sea is 22 degrees. So the angle of depression is 22 degrees. So here's the person, top of the cliff. Here's our cliff. The person standing here on the top of the cliff. It's 200 metres high. Okay, that's where my triangle, my right angle triangle would be. The angle of depression, you look straight out horizontally, then look down that angle, which is 22 degrees. Okay, and there's the boat out in the water. So that would be the diagram. If I wanted to use this triangle inside here, this being my triangle, then I would have to write 22 degrees in here. Or I could have used this triangle out here, and the 22 degrees is already in there. That would be the right angle up there, and this length here is still 200 from here to here. It's still the height of the cliff. So you can use either triangle. Part B says the angle of elevation to the top of a tower 50 metres from its base is 55 degrees. So the angle of elevation, the person looks out horizontally first, and then goes up in until it's 55 degrees to the top of the tower, and you're told the length from the base of the tower is 50 metres. So there's my right angle triangle drawn there for me. Okay, the next slide we should do an example. So let's read through this example. Let's highlight the important information. It says here, from a lookout tower, Callum spots a bushfire at an angle of depression of 25 degrees. If the lookout tower is 40 metres tall, how far away to the nearest metre, so we need to write our answer in the correct form, is the bushfire from the base of the tower? Alright, so first of all we'll try and draw a diagram which would do this for us. So Callum's up here on a tower, so my artistic skills are very limited. So it makes it look like a tower. You'll see on the next slide I've got much better Callum, I don't know, there's Callum, then looking at and there's a bushfire here. Probably need a bit of yellow in there as well. Oh. Why is that going yellow? There we go, a bit of fire, looks like a fire. Okay, Callum's spotted this fire, and so the direct line from Callum to the fire is this, but his angle of depression is, you need to look out horizontally first. Right, so like that. And the angle of depression is the angle down from the horizontal to that line of sight is 25 degrees. Whatever if the tower is 40 metres high, so this is 40 from here to here. You can, if you use the triangle inside here, so that would be the right angle triangle there, the tower and thing, so that using our alternate angles, that angle of depression is outside this triangle, so that would be 25 there, or you could say that's 65 there because those two angles add up to 90. Alright, and we're asked to find how far away is the bushfire from the base of the tower. So I'm going to call this X along here. How far away is the bushfire from the base of the tower? Alright, I'm going to use this triangle. I'm going to use the 25. So I'd be saying over here, 40 is opposite the angle and X is adjacent to the angle. The hypotenuse is sitting over here, but we don't have any length of that. So opposite and adjacent we use tan, so we say tan of 25 degrees is equal to the opposite, which is 40, over the adjacent, which is X. The unknown is underneath. The unknown is underneath, so we swap that with that, so that leaves me with X is equal to 40 divided by tan of 25, and we type that on our calculator, and that comes out to 85.78. But read the question, it says we want the answer to the nearest metre, so that's nearest to 86 metres is the answer we're looking for in this question. Okay, we'll proceed to the next slide.